This video is for additional information on assembling the GDS Instrumented Hook Cell and is intended to be used alongside the handbook. Please ensure you have read this handbook prior to assembling the cell to ensure an understanding of the safe use, maintenance and other components of your system. To start assembling the internal components of the cell, ensure the cell base is securely located on the assembly jig. Place the assembly aid through the center of the cell base until touching the assembly jig. Place one of the two sample spacer rings down the assembly aid, with the chamfered edge facing downwards. No force should be required to fully locate the ring into the cell base. Slide one of the small fixed rings down the assembly aid with the chamfered edge facing upwards. Now place one of the larger rings with the chamfered edge facing upwards into the center section of the cell base. Ensure this is located flat against the sample ring. Apply silicone grease to all sealing surfaces of the sample membrane, top and bottom. Slide the membrane over the assembly aid. A specific orientation of the sample membrane can be set for reference of acoustic sensors. A common approach is to use north, south, east and west. Once the orientation has been set, firmly push the membrane securely against the sample spacer ring.
Apply silicone grease to the push-fit cantilever inserts. The 4 insert locations are central to the membrane. The insert holes on the membrane have a sealing ring which will locate into the corresponding groove on the insert. When fitted correctly, you will feel a click as the seal locates into this groove. The membrane has 12 additional push-fit locations. If any port will be unused once final assembly has been completed, it is advised at this point to fit any blank inserts into these locations. Pick up the radial caliper, noting that this is a very delicate arrangement. Handling the caliper should be done from the outside edges of the lower ring, avoiding pressure against the 4 measurement arms. The caliper also has exposed wiring that can be easily damaged if not handled correctly. Wind the feet on the radial caliper out until flush on the upper side. Place the radial caliper over the membrane, aligning with the caliper inserts. Place one spring over each measurement arm before winding the connection pins so they are almost touching the caliper inserts. Readjust the feet for better alignment if required. Connect both the X and Y plugs into the corresponding feed-through, identified from the cable identity tag located on the exit cables from the underside of the cell base. To connect the feed-through plug, lightly insert the plug into the correct orientation. The plug should locate in place by dropping down slightly. Do not force the plug further, as it will locate more securely when the collar is tightened. When tightening the plug, only rotate the collar on the lower section. You may need to gently push down the fitting after a few rotations for this to fully locate at the bottom of the feed-through connector. Once fully tightened, it's advisable to loosen the collar by a quarter of a turn, as specific testing conditions can cause the plug to become difficult to remove when required. Using the GDS Lab software, zero the X and Y displacements. Now carefully wind in the connection pins until just touching the caliper insert. Monitor the X and Y displacements when adjusting the pins as to not offset the displacements and detect when contact has occurred. This ensures that the measurement range is not exceeded when the caliper is sat in its zero position centrally around the membrane. Attach both the upper and lower springs on each arm, making any final adjustments where necessary to maintain a central position. Once correct, remove the upper spring and fix the locking nut in place. This process should be done in pairs.
To fit the horizontal acoustic velocity transducers, apply silicone grease around the sealing face and insert into a predetermined location on the membrane. The AV holes on the membrane have a sealing ring which will locate into the corresponding groove on the transducer tip. When fitted correctly, you will feel a click as the seal locates into this groove. Each pair will need to be located on opposite sides to each other. The transducer tip has been specifically designed to match the profile of the sample. When inserting the transducer, the cable will exit on the left-hand side as shown here. Connect both the red and yellow plugs into the corresponding feed-through. To connect the feed-through plug, lightly insert the plug in the correct orientation. The plug should locate in place by dropping down slightly. Do not force the plug further, as it will locate more securely when the collar is tightened. When tightening the plug, only rotate the collar on the lower section. You may need to gently push down the fitting after a few rotations for this to locate fully at the bottom of the feed-through connector. Once fully tightened, it's advisable to loosen the collar by 1/4 of a turn, as specific testing conditions can cause the plug to become difficult to remove when required. The membrane provided is suitable for up to 2 pairs of horizontal acoustic velocity transducers. Any unused locations on the membrane will need to be sealed prior to fitting the cell wall. This can be done by applying grease to the sealing face of the blanking plugs provided.
There are 12 insert locations for additional sensors located on the membrane. Apply silicone grease to the AE sensors or any blanks required. The insert holes on the membrane have a sealing ring which will locate into the corresponding groove on the insert. When fitted correctly, you will feel a click as the seal locates into the groove. Location of each sensor around the specimen can be noted using a method such as north, south, east and west to help identify seismic activity locations.
Clean any residue and contaminants from the upper and lower sealing grooves. Apply a bead of silicone grease into the lower back corner of the cell base groove. Place the backing ring into the groove, taking care not to open up the ring too far, avoiding damage to its shape. Locate the join at the front, then push the seal down into the grease. Work from the back, around both sides, towards the join, ensuring the silicone holds the ring in place. For the upper sealing plate, place this upside down. The 2 key holes located on the sealing plate identify the top face. Apply a bead of silicone to the lower back corner of the sealing groove, fitting the backing ring as before, working from the back to front, ensuring a good fit. Apply silicone to the top surface of the backing ring and the O-ring. Each time the cell is rebuilt, a new O-ring should be used in both the upper and lower sealing grooves. This is to maintain the sealing efficiency of the cell. Place the O-rings in each of the sealing grooves making sure the backing ring stays firmly in place.
The cell base and cell top will have a molecular grease applied. This should be topped up when necessary to avoid seizure of the threads. Clean the sealing faces located inside the cell wall. Use a silicone spray to lubricate the threads inside the cell wall. Apply a layer of silicone grease to the upper and lower sealing faces, making sure to cover the chamfered edge.
Lift the cell wall up and remove the feet. Remove the assembly aid from the center of the membrane, as this will foul on the lifting points. Lower the cell top centrally over the cell base, making small adjustments as required. Slowly start rotating the cell wall as it approaches the cell base. This will help align the threads. Do not lower too far, as the weight of the cell will sit on the upper thread, reducing the ability to smoothly rotate the cell wall. The lifting device should always be taking the weight of the cell during the fitting process. Looking from the side, it is important to monitor the depth of the assembly jig pins. If the cell base is sitting fully on the pins, the weight of the cell will lock the thread. When rotating, the cell base will lift. If this comes off the pins, you will need to lower the cell assembly back down to enable rotation. Once the thread is engaged and the cell base is around the midpoint of the assembly jig pins, rotate around one turn before lowering the cell top a small amount. This should enable the cell base to maintain a central location on the assembly jig pins. Once the O-ring reaches the sealing face, the rotation force will need to increase. At this point, the assembly jig will need to be held in place to avoid rotation of the lower assembly. Care should be taken when holding the assembly jig in place, as the valve panel has components on the underside that can catch your hand and any wiring that has not been properly moved out of the way. The cell wall is fully located when the cell base is flush with the bottom edge of the cell wall. The lifting points will need to be removed from the cell wall at this point, enabling fitting the cell top.
Locate the bleed pipe inside the upper lip of the membrane. This will be used later when filling the cell with oil, to remove the pocket of air that will form within this space. If not already done, apply silicone grease to all sealing surfaces of the sample membrane. Place a small fixed ring into the membrane with the chamfer facing downwards. Place the sealing ring inside the cell wall using the handle provided. Once loosely in place, gently tap the sealing ring into place, working around in a circular motion to ensure the sealing plate lowers evenly into place. The cell flush valve should be opened to allow the air to escape and allow the sealing plate to locate correctly. Fit the last fixed ring in place with the chamfered edge facing downwards. If necessary, adjust the membrane to sit flush with the top of the sealing plate. Place the second sample spacer ring on top of the membrane with the chamfered edge facing upwards. Reinsert the assembly aid until touching the assembly jig. Fit the lifting points onto the cell top for safe lifting and the placement of the cell top. Gently lower the cell top onto the cell wall. If required, use 2 persons. Slowly rotate the cell top until the thread engages correctly. Do not force the top to rotate if it is not moving freely. Unwind and re-engage the threads. Continue to wind the cell top until flush with the upper edge of the cell wall. The assembly aid is best used up to the end of this process to ensure all the internal components remain central. It is not, however, shown in this video. A pressure test can be conducted at this point using just the assembly aid to check the system is leak-free.
If you have the temperature option on your cell, remove the lifting points from the cell top, place the thermal top plate onto the cell and refit the lifting points onto the cell wall. Fit both halves of the thermal covers and latch together.
Lift the completed assembly up and fit the feet stubs. Locate the pedestal assembly. If axial displacement transducer bars are fitted, ensure the location of the assembly is correct. Locate the pedestal support bars onto the feet stubs. Screw the feet in place. Use an oversized washer between the feet stub and upper fixing nut to restrain the support bars. If conducting saturated testing conditions, connection of the pipework is required at this stage. Lower the cell assembly back down. Remove the lifting points to allow placement of the Topcap assembly. Place a sample inside the cell. Lower the Topcap assembly into place. Connect the saturation line if required. Center the axial displacement transducers if fitted. When using vertical acoustic velocity transducers, the cable exits must align on both the Topcap and pedestal to ensure the orientation of shear waves are matching.
To fit the optional lower lifting aids, slide into place in the locations shown.
To disassemble the cell, follow the process in reverse order. Gloves are advised to avoid contact with the grease and oil. Noting two areas that require additional steps. To remove the upper sealing plate, use the removal tool provided. Once the upper sealing plate has been removed, a syringe or similar device should be used to remove the excess oil left in the cell base recess.